Good morning. Here's your joke of the day. It's a little bit better than others that we've had. One note on the quiz. Most everybody handed it in. A couple people did not, but when you are asked to draw them, I'm not allowing this. That proves to me that you got it off the internet. I don't want that. You have to draw it the way we've been drawing them. Like this. Okay? This is not allowed. So I'm going to give you until noon today to resubmit if you did that. That's for the bonus or for the other two drawings. It has to be like this. Otherwise, I'm not taking it. Okay? So by noon today, make sure that you have the quiz completed. All right? All right. We're going to be going over the homework, naming, drawing alkanes, the type sheet that that was assigned. It probably took you some time, but it's good practice. And then today we're going to introduce functional groups, which is the second to last thing in this unit. All right, so let's take a look here. I think it was this one. Okay, I wanted you to do this one. Let's see if we can get a little bit closer. All right, so this is going to be a good review for you. All right. Step one, do I have any double or triple bonds? Well, I've got a double bond right there. There it is. So, since I do have that double bond, I'm going to, that tells me that I've got an alkene of some sort. So how many is my longest carbon, or carbon chain? 1, 2, 3, 4, 5. Now remember, with double and triple bonds, you have to name the carbon on which the double or triple bond is. So I could name this 1, 2, 3, 4, or 1. So as a reminder, you're going to want to use the lowest number. So this is 1, 1, 2, 3, 4, 5. Reminder, meth, eth, prop, bute, and pent. So this is 1-pentene. 1-pentene. Okay? Number 2. Step 1, is there a double or a triple bond? Yes, there is. You can see it. The double bond is here. Second question, are there any substituent groups? Here's a substituent group in the fluorine. So, because I've got that, that's going to change my naming. Okay? Next, how do I number these? Do I number from right to left or left to right? Well, what I just told you up there is if you have a double bond, that has to be at the lowest number. So I have to start here at 1, then 1, 2, 3, 4. So when I'm naming it, I know it's a lot of rules and gets confusing. When I'm naming it, I name my substituent group first. So here's my substituent group, and I have to name the carbon to which it is bonded. So this is 3-fluoro. And then my double bond. 1, 1, 2, 3, 4. 4 is meth, eth, prop, bute. So this is bute. It's not butane, it's butene. 3-fluoro, 1-butene. Okay? All right. Same process each time. Do I have any double or triple bonds? Yes, I do, right here. do I have any substituent groups? Those are groups that stick off of the main chain. Well, here's one right here. And you can see that that substituent group has one carbon in it. And since it has one carbon in it, that is a methyl group. So I have to number my carbons. 1, 2, 3, 4, 5, 6, and 7. That's my longest chain. So where's my substituent group? It's on number 6. So this is 6. And what is the group? One carbon is a methyl group. So that's 6 methyl. And then I've got a triple bond here on carbon number 1. So that's 1. I've got 7 for my total. So that's hept. And since it's a triple bond, my ending is going to be -ine. 6 methyl, 1 heptine. 6 methyl, 1 heptine. Okay, hopefully you got that one. Let's move up and erase. I like this big eraser. Number 4. Okay, same question. Do I have any double bonds or triple bonds? Nope. Question 2. Do I have any substituent groups? Yes. I've got a fluorine there, and I've got a 2-carbon addition there. So I'm looking at, what do I name this? Well, what about my carbons? Should I go 1, 2, 3, 4, 5, 6? That would give me substituent groups on 2 and 3. Or should I go 1, 2, 3, 4, 5, 6, giving me substituent groups on 4 and 5? Well, by now, hopefully you know that you should take the lower of the 2 combinations. So this is 2, 3, something. My next question is, well, this is the combination that I'm going to use as far as left to right. So that's 1, 2, 3, 4, 5, 6. What's this group? 2 carbons. 1 is meth, 2 is eth. So this is ethyl. And this is fluoro. So how do I decide which one comes first? I'm going to go in alphabetical order. So E, ethyl, comes before F. So I think we're ready to name it. 3 ethyl, 2 fluoro. Now my full name, 1, 2, 3, 4, 5, 6. That's hex. Actually, I shouldn't. That actually does not get dashed. Whoops. Fluoro, hex. And are there any double bonds? No, so that's hexane. 3 ethyl, 2 fluorohexane. All right, next one. Substituent groups. Are there? Oh, I like the purple. Any any double bonds or triple bonds? No. Any substituent groups? Yes. 3 of them. How do I number? How do I number? Should I number 1, 2, 3, 4, 5, 6, 7, 8? That would be 4, 6, 7. Should I choose 4, 6, 7? Or should I choose 2, 3, 5? Well, if you've been paying attention, we're going to choose 2, 3, 5. It's the same thing up here. Which one do I put first? Again, it's going to go into alphabetical order. So what comes first? B comes before C, which comes before F. So here are my carbons, 2, 3, 4, 5, 6, 7, and 8. I've got 3 bromo, 2 chloro, whoops, dash chloro, 5 dash fluoro. What's my long? 8. That's oct. No double bonds. That's ane. 3 bromo, 2 dash chloro, dash 5 dash fluorooctane. Okay? Hopefully you got that one. Number 6. Chloromethane. Well, here's methane. Chloro means I've got a chlorine on it. And the rest are hydrogens. You could put the hydrogens if you wanted. You don't have to, though. Does it matter if I put the chlorine here or here or here or here? No, because think about it. Here's what this is showing. If I put the chlorine here, I'm just moving the molecule like that. If I'm putting the chlorine here, it's just like doing that. Okay, so it doesn't matter which one you put it on. Number 7, let's change colors. 2-methylpropane. Prop is 3, 1, 2, 3, and 2-methyl. Means I've got a carbon sticking off of that one. Okay? Pretty straightforward. Should be a dash here. Let's change colors. Let's make it black. All right. 1 bromo, 2 fluoroethene. Okay, ethene is 2 carbons, and the ene tells me that I've got to have a double bond there. 1 bromo and 2 fluoro. Now, I've been training you to make sure that you put 4 bonds around every carbon, so make sure you do that. Now, you can see the angle that I've made here. Don't worry about the angle. If you went straight up and down, that's okay. But if we were to build these models, then these would have to be sticking off like that. So there you are. You've got 1 bromo, 2 fluoroethene. Now, you might be thinking, ene, when I have a double bond or a triple bond, I'm supposed to be numbering which carbon it's attached to. Well, look, there are only 2 carbons, so each one of them is number 1 if you want to think of it that way. Okay? It can't be any other number other than 1. That's why they don't put the number there. All right? Let's erase. Let's see if we can, I don't know if I can move up here, so let's look. Not much. All right. So, number 9. 5-ethyl, there should be a dash here. 3-octine. So, 8, 1, 2, 3, 4, 5, 6, 7, and 8. Ine. Well, that tells me there's a triple bond. And then 3 tells me where it is. So 1, 2, 3. I've got a triple bond here. Takes care of that. Now 5-ethyl. So 1, 2, 3, 4, 5. Ethyl is 2 carbons. I can't have a carbon here and a carbon here. That would be a dimethyl. This is ethyl, 2. All right, fill the rest in. Make sure each of the carbons has 4 bonds. Look here, be careful. People automatically put lines here. You got to be careful though. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. So I can't put anything more around those. And there you go. There's 5-ethyl 3-octine. 5-ethyl 3-octane. And the last one is 3-methyl. There should be a dash here and here and here and here. 3-methyl, 4-bromo, 4-propyl, 2-nonene. This is a good one. You can put it down here. I'm going to erase this so it's a little bit more clear. All right, where do we start? Right here, nonene, that's 9. I'm going to switch colors. 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 2-nonene. Ene tells me that there's a double bond. That's number 2. Okay, I'm done with that. Now I can go backwards or I can start at the beginning. It doesn't matter. Once I've satisfied this, then I can go whichever way I want. So I guess right now I'll start at the beginning. So 3-methyl. 1, 2, 3. 3-methyl. A methyl is a single carbon. That one's done. 4-bromo. 1, 2, 3, 4. This is a bromine. So that one's done. 4-propyl. 1, 2, 3, 4. Okay, off of the second, off of the same carbon, I've got propyl. Propyl is 3. Woo. 1, 2, 3, 4. Now I'm just filling in my lines from my carbons. 1, 2, 3, I need one more. 1, 2, 3, 4, that can't have any more. And then fill the rest of them in. All right, that's 3-methyl, 4-bromo, 4-propyl, 2-nonene. All right, okay, let's get to this. We'll only look at alcohols today, and then we'll pick up on it tomorrow. Okay, so a functional group is a group of atoms that replaces actually one or more hydrogens. The group replaces. And because of that, it gives its specific properties. All of these functional groups are going to give different properties to the carbon chain to which they are attached. Okay, so the first one we'll learn about today is alcohols. An OH replaces a hydrogen. The OH group is called a hydroxyl group. And we've seen this before. We've seen this in bases. So the OH group does not separate. Because of that, they're not bases. You may remember a base is going to be a metal and then hydroxide. Okay? So this group here is called the hydroxyl group when it is attached as an alcohol. Here it's called a hydroxide group. The OH group does make alcohols slightly polar. Remember, polar means that there is a slight charge on one side of the molecule compared to the other. And just like water, which is polar, if you have polar and polar, like dissolves like. So alcohols are soluble in water. You can dissolve them in water. All right? How do we name these things? Well, you find what the longest chain is. You also name what carbon onto which the hydroxyl group is attached. And then you finish it off by putting the chain name with OL. Okay? So alcohols are going to end with OL. And as a reminder, these things are found, all these functional groups are found in table R. So the first one we're looking at here is alcohol. It has an OH, and we'll talk about that R here probably in a minute. That R essentially means the number of carbons that are also attached to it. And then it ends with OL. you draw the OH with it. All right, so let's look. Alcohols actually are classified into 3 different types of alcohols. You've got a primary alcohol, and in a primary alcohol, the OH group is attached to a carbon that is only attached to one other. Okay, so primary means one or first. Sometimes you'll see it as a 1 with a degree sign. So, these are all examples of primary alcohols. So here's carbon number 1, 2, 3, 4. So wherever this is, that's going to be the lowest. We're going to try to get it to the lowest carbon. So this is 1-propanol, OL. Why? Because that's meth, eth. Ooh, I made a mistake here. This is butanol. 1, 2, 3, 4. This is 1-butanol. My fault. Okay? Oh, I did this last time too. Look. It's just a typing thing. It's right here. 1-butanol. Sorry. And this is how you would show it in the condensed form. 1, 2, 3, 4, and then an OH. So this, all of these, including this, that's all 1-butanol. I didn't see that. It wants me to draw 1-propanol. Prop is 3, yes? Meth, eth, prop. So, I can just draw it there. There's your 1-propanol. How would I draw this? Condensed, CH3, CH2, CH2, and then my OH. Okay? So this, again, this R is what we call the hydrocarbon chain. So from here over, this is the R group. ROH. In this case, R equals CH. C3, H, 1, 2, 3, 4, 5, 6, 7, H7. Okay? So that's a primary alcohol. Secondary alcohol, the OH group is attached to a secondary carbon. Now what does that mean? That means that that carbon to which it is attached to 2 others. Okay? 2 others. Now how do I name it? Well, I've got 4 carbons, meth, eth, prop, and but. Is this 2 or 3? Well, this is my alcohol group, my hydroxyl group. I want it the lowest, to have the lowest number. So I have to name the number to which it is attached, so that's 2. And then what's my long? Meth, eth, prop, and but. Butane. I take the E off and add OL. 2-butanol. Think we can draw 3-hexanol? Well, hex is 6. 1, 2, 3, 4, 5, and 6. And third one has a hydroxyl. Now when you're drawing this, be careful. Don't draw it like this, because the hydrogen only can make 1 bond. You can't do it like that. You've got to have the carbon attached to the oxygen. Carbon has to be attached to the oxygen. And here's the model of, this is actually ethanol. And this is the reason, because oxygen can make 2 bonds, hydrogen can only make this 1 bond here. So drawing it like the carbon attached to the hydrogen, that would actually be wrong. So 3-hexanol, that's 1, 2. Then I fill in my bonds. Okay? This is a secondary alcohol, again, because the carbon to which the hydroxyl group is attached to 1, 2 other, 2 meaning secondary. All right, the last one is tertiary. The OH group is attached to a tertiary carbon. And what does that mean? They're attached, that means it's attached to 3 other carbons. Okay, so this particular alcohol over here is a tertiary alcohol. Now, this introduces something new. That carbon is attached to 1, 2, 3 other carbons. Because of that, it's a third order or a tertiary alcohol. Now, how do I name this? Well, does it have a substituent group? Yes, it does. Here's the substituent group, and that is a methyl group. What carbon is it attached to? It's attached to 2. So this is 2-methyl. And now I have to name this because that OH group could be attached to 1 or 2. So I have to name it 2, and then meth, eth, prop, propane. This tells me end it with an OL. 2-methyl 2-propanol. Okay? Draw 3-methyl 3-butanol. Well, but tells me butan means 4. 1, 2, 3, and 4. 3-methyl. 1, 2, 3. And 3-OL. And if you're really paying attention, you can see that this is named incorrectly. Can anybody see it? What carbon is this? That's got to be carbon number 1. Why? Because we want this to be on the lowest number. So this really should be 2-methyl 2-butanol. Naughty. Okay? The last little chunk is di and trihydroxy alcohols. Some substances can have 2 or 3 alcohols attached to the same carbon chain. Okay, so di again means 2, tri means 3. All right? So, how would we name this? Well, I've got 2 hydroxyl groups, but they're attached to different carbons. So, I'm going to do 1, 2. How many are there? There are 2. And this is meth eth. And that we name that diethanol. 1, 2 diethanol. 1, 2 di, because there are 2 of them, ethanol. All right? Number 3. Sometimes you might see this as 1, 2 ethane diol. Okay? Probably should go with this one. Let's look at this one. 1, 2, 3. It's not ethane, no, it's what? Meth, eth, prop. That's prop. Propane. And the prefix for 3 is tri. 1, 2, 3, propane triol. Okay? This one's actually called glycerol. That's its common name. It's a byproduct in soap making. It's used to make plastics, drugs, cosmetics, food, nitroglycerin. Right? So that's the end of that. Your homework is Regents Review Book 200 to 201, only the evens. And I want these drawn. So the last number on the right-hand corner, top right-hand corner, drawn, not like this, but like this. Draw them. Don't look them up and just put them down. It's too easy that way. All right, have a good week.